This is June 2023, paper 1-2. The threshold was 29. So that was question number 17 we did. And now we are starting from here. What is meant by the spring constant of a spring?
F is equal to kx, so x will be force per unit extension, so D.
What is meant by the spring constant? Spring formula is now look at this question. A child holds a thin metal wire that is attached to a kite. The graph shows how the extension of the wire varies with its tension. Extension of the wire varies with the tension. It looks to be a Hooke's law follow-up. A gust of wind increases the tension from 100 to 150. What is the change in the elastic potential energy of the wire caused by the gust of wind? Only the unit conversion is looking to me, but I think it looks to be an area of trapezium. The unit is millimeter. Now find the area.
It will be 19 millijoule.
19. So 19 is the question number, and you say 19 is the answer. Oh. Then he's not converting millimeter to meter. A microphone detects a sound wave The microphone is connected to a CRO oscilloscope. The shape of the trace on the screen of the CRO is shown. Which property of the sound wave can be determined by using only the measurements of the horizontal distance on the screen and value of a control setting? Horizontal axis is time and vertical axis is voltage. This is time axis and this is voltage axis.
So we can find the frequency.
Either the frequency or time period. A longitudinal wave is traveling from left to right. The graph shows the variation of the displacement of the particles with distance along the wave at one instant in time. Displacements to the right are positive, displacement to the left are negative. From left to right. It's a longitudinal wave. So when it is traveling left to right, going like this, it is traveling left to right. This is the wave which is traveling left to right, and the particles would be, if we consider the particle in this motion, which label point represents a compression. So when particles are moving towards each other, it would be compression. And when particles are moving away from each other, this is a sketch. And remember that at the center of a compression and at the center of a rarefaction, what happens that the displacement, this is 21. This is actually a displacement time graph, but you have to mark for the memory of this, the notes there. The compression is a region of high pressure and displacement is positive and displacement is negative. And here the display at B displacement is 0, D displacement is 0. At the center of a compression or at the center of a rarefaction, displacement becomes 0 because they stop.
So would it be B?
At the center of a compression, or at the center of rarefaction, the displacement is 0. This is compression. Now B is right, but why not D? Positive displacement means the particle is moving to the right. And negative displacement means particle is moving to the left. So this is the position. There are two answers possible, B and D, because both have zero displacement. Now we have to see this diagram also, compression and rarefaction. So why not D? This is a question.
Because the displacement is becoming positive.
From plus to minus. The point is that at B, you are going from, the wave is going left to right. This is a very important thing. If you mark first, I have marked it on my diagram also, that the wave is traveling. Look at this, the wave is traveling from left to right. The wave is traveling from left to right. So what is B? Actually, B is changing plus to minus. And what is D? I mark here, B is changing plus to minus and D is changing minus to plus. So that is the important point. It means that you are shifting from plus to minus. The displacement is plus when you're moving to the right. So this is the point where compression occurs. Then what happened at D? Actually, D will be a rarefaction. D will be a rarefaction. So that was a challenging question, and a source X emits a sound wave of constant frequency F. The wave is subsequently received at a stationary detector Y. Okay. The frequency of the wave that is detected by Y is less than F. The wave is a bit better stationary. Do you think it's a looks to be a case of Doppler effect? Because one side he says constant frequency, then he says less than. How this is possible until it's a Doppler effect?
It will be Doppler effect, so then we don't consider A and
The
B.
Doppler
We
effect.
see B.
So I should reject A and B.
Yeah.
If it is Doppler effect, I would reject A and B. X is moving away from Y. So what's the rule? When you get closer to the listener, the apparent frequency increases. And when you go away from the listener, the apparent frequency decreases, right?
Yes. So
So
it will
then
be C.
a beam of visible light in a vacuum. Look, we're talking about this question. It came that the memory, what could be the frequency of light? Actually, this is a big list and people have to learn it, but it's a visible light. The frequency of the light. So do you remember this table 23?
Yeah, so it will be D. 10 to the power of 14.
You learn it by power of 10.
Yeah, I learned it by power of 10.
This is smart because numbers cannot be learned and no need to learn the numbers because the power difference is visible. Then comes polarization of light. A vertically polarized beam of light of intensity I naught is incident normally on a polarizing filter. The transmission axis of the filter is at 45 degree to the vertical. The beam of light transmitted by this filter is then incident normally on a second filter. The transmission of axis of the second filter is horizontal. Is 45 to the vertical and the second one is horizontal. What is the intensity of beam of light after transmission through the second filter? Second filter, he has placed horizontal. First is at 45 degree. What is the formula then? There are two filters. What's the formula?
I equal to I naught cos square theta.
I is equal to I naught cos theta. Right. Incident is I naught.
There's a square also, right?
I naught cos square theta. Yes, sorry. And this is the first. This is the first filter. Should we apply the rule of half? Because for second one, the angle is 90 perpendicular axis. So this is the working B part. A stationary wave is formed by two. Let's see the comments there because this question was difficult. Examiner says around half the candidate answered this question correctly. From Wallace's law, the intensity of light I1 passing to the first polarizing filter is this. The transmission axis of the second filter is at 45 degree to the transmission axis of the first filter. The intensity of light passing to the second filter is then therefore this. A stationary wave is formed by two progressive waves traveling in opposite direction along the same line of travel. Which statement about the two progressive wave is not correct? This question is about a stationary wave. And the two progressive waves are incident and reflected waves. Which statement about the two progressive wave is not correct? They must have the constant phase difference. Now, this is again a concept to remember that constant phase difference, the word constant phase difference means coherence. Now, is coherence necessary? Is coherence necessary for coherence? Is it necessary for the formation of stationary wave?
No.
Coherence is a condition. Coherence is a condition for mainly for interference, but he says two waves is not correct. They must have the same frequency. Is it necessary?
No.
They must have the same wavelength. It should be because without the same wavelength, superposition won't occur. They must travel at the same speed. It is also necessary. This is a correct statement. This is also correct. Same frequency should also be correct because the same nature. They all should be correct because this is according to principle of superposition. The word is must. It is not necessary because coherence is a condition of interference. The sound from a loudspeaker placed above a tube causes resonance of the air in the tube. The stationary wave is formed with two nodes and two antinodes as shown. The tube has height 60 centimeter. The speed of the sound is 340. What is the frequency of the sound? Node to node is lambda by 2 and node to antinode is lambda by 4. So how much this total will be? How much is this?
3/4 lambda.
3 by 2 lambda.
No, 3/4 lambda, right?
Oh, sorry, 3 by 4 lambda, right? 60 centimeters. So let's find the lambda. He's asking for the frequency.
It will be 425, and that's closest to 430.
How much you're getting?
425.
A continuous progressive water wave in a ripple tank passes through a gap in a barrier and diffracts. The width of the gap is greater than the wavelength of the wave. The width of the gap is greater than the wavelength of the wave. Now, this is a technical issue. Actually, the gap should be narrower than the wave. By rule, the width of the gap should be narrower than the wavelength of the wave. Which change causes the wave to spread over a larger angle as it passes through the gap?
So we decrease the width of the gap.
That is the only thing we should do, because if we make the gap narrower, then we can cause diffraction. Then are you there?
Yes, sir.
But you're not answering anything. I hope you remember now that we have a paper.
Yes, sir. Yes.
The diagram shows a view from above of a double slit interference demonstration. L is a monochromatic light source with a vertical filament. B is a barrier with two narrow vertical slits. And S is a screen upon which interference fringes form. If one of the slit is covered, what is the intensity at the same point on the screen? If you cover one slit, you will allow half light to pass. Intensity is proportional to the square of the amplitude. He's covering one of the slits. So if we cover one of the slits, half of the light will pass. Achha, he's talking about the center of the central maxima. He's talking about central maxima. And the rule says intensity is proportional to A square. Now you people have to help me. I have reminded this formula also. Half of the light is gone. Yes. The formula can be used, but we can guess it directly that half light will pass means half A, which means that the intensity will be 1/4 I, because you have to square it. So after squaring, it will be 1/4. Okay, then good, but you have to start contributing. 29. Green light of wavelength 550 is incident. This is lambda. Normally on a diffraction grating and produces a diffraction pattern on a screen placed 3.5 meter from the diffraction grating. The third order maximum, and he has given us some data in the line. What is the distance between two adjacent slits in the grating? The distance between two adjacent slits is D. The formula says N lambda is equal to D sine theta. If I mark the angle theta here, this is my 90 degree. So this is my opposite in trigonometry, and this is my adjacent. So how should I find angle? Help me to find the angle.
It will be 12.
Angle is 12,
Yeah.
and the calculator should be in degree mode. What is the distance between, now we have the data, everything in our hand, and we can work out we can work out the D. Nanometer, oh, it's nanometer. This is the one. Now you have to solve it.
7.9 times 10 to the power minus 6.
7.9, 10 power
Minus 6.
7.9, 10 power minus 6. We are getting this answer as C. Send your feedback, please. No problem, but you can calculate the answer. You can tell me. Right. Which charge can be carried by a charge carrier? This is about quantization of charge. This is a very unique MCQ and very less appeared. Quantization of charge. Say then, what is quantization of charge? It's a very rare topic and it comes very less. Charge on any particle is always an integral multiple of the charge of an electron. Now, you have to divide every charge here by this elementary charge, and you need to see where you get the integral multiple, where you get the whole number. To divide every option by the charge of an electron. First one is looking already bouncing. It is even less than 1.6. So that should be neglected. I cancel it out.
That's 2.5, so it's wrong. It's C.
What is the answer for, what answer is coming for B?
2.5.
2.5, right? So that is also rejected because
Oh.
electrons exist in whole numbers.
For
So
C,
what
it's
about C?
3.
Coming as 3. Now this one,
5.6.
5.68 minus 30. No, then how the power can be coming? Power should be decreased because power is cancelling. They are both 10 power minus 19.
It's just 5.68.
Ah, because what the power will be cancelled, na? 10 power minus 19. The both are same. So that was a good question because I saw this topic after a long time. Many people even do not prepare it. A resistor of resistance R is connected across a cell of electromotive force E and negligible internal resistance. Which single charge to the circuit would lead to the largest increase in the power dissipated in the resistor? Power has a formula I square R. Now this is a tricky question because in a circuit we have a resistance, internal resistance is negligible, so no power is going there and all the power would be coming to the resistor. He says in a tricky way the word single, only one. Let's write down the formula. Here the voltage is EMF. V is equal to E. We have to see all options. Largest increase. You have to see this word, largest. So
So
if
it will
I
be either
if
A or
double the
D.
EMF, please go ahead.
It will be either A or D, right?
Either A or B. Largest increase. So C or D should be cancelled. No, actually,
A and D, right?
what about R? If I double the R, I will get more power. If I double the R in the formula I square R, if I double the resistance, more power will be dissipated. if I halve the value of E, C can be taken out. We can say C is not possible, but other letters are getting some options always. So double the value of E. If I double the value of E and I use the formula P is equal to VI, if I write P is equal to EI, and P is equal to E square upon R. Second formula is P is equal to E square upon R. So now I have an option here, because if I double the EMF, I can get power 4 times. The problem is there, he is using the word largest. When you increase the EMF, power will increase. When you increase the resistance, power will increase. But he wants largest increase. So power has an option. Power in one formula, power has a square on it. When power has a square on it, you can get power 4 times. So that is the possibility of 31. What you people say? I need the suggestion, explanation actually, because in one formula, power has a square. Any contribution? Okay, I underline this word. Look at this word. He says resistor. If I consider the resistor approach, then I have to cancel the I square wala formula, and I have limited option of this formula here. Why this formula? Because he is not talking about current. All options are ER. So I have only one option. P is equal to E square upon R. P is equal to E square upon R. In B, double the R will double the power. In A, double the value of E. E has a square, so it will be 4 times, and it will be 2 times. An electrical cable is made up of one thick strand of copper wire that is surrounded by 8 thin strands of copper wire. All 9 strands of wire are connected in parallel with each other. A cross section of the cable is shown. This is normally called the cables which we use for air conditioners and other heavy devices. Each thin strand of wire has cross-sectional area and length L. A thick strand of wire has cross-sectional area 4A and length L. The cable has total resistance R. Which expression gives the resistivity of copper? What's the formula? R is equal to rho L upon A. Let's talk about the thick version, the thick strand first. Length is L and the resistance is 4A. And let's talk about the thin. Will be resistivity rho L upon A. How many of them are there? 8. If they are in parallel, how should I combine them? I mean, what formula should I use? What's the formula for parallel combination?
1 divided by R equals
Well, we
to,
can use that also, but if there are overall, there are 2 resistors. One is a combination of 8. Can we use that R1, R2 upon R1 plus R2?
but there's like multiple thin wires, so
But they all
but
are
which
in parallel. And I combine them as one wire. So just imagine the 8 wires are combined to become one wire of thickness into 8. Actually, you're right. You can, in that sense, you can write it 8 times. But when you write it 8 times, they all are in one area. So it will be again into 8. Otherwise, I have to write 1 upon R1 plus 1 upon R2. And I have to make 9 fractions. So this is my plan, and I want to use that rho L upon A into rho, oh, 4A, sorry. Then no contribution coming up. Okay, I hope everything is fine and things goes forward. Obviously, A level is hopefully once going to end. Now, just do these calculations. This calculation need a good release of maths. So we can take it square function L squared. There is a 8 in the numerator and there is a 4 in the denominator. So I can write 8 upon 4 and rho square L square upon A square. Here I have to take LCM or I can add it directly, but otherwise I should take an LCM. Rho L upon A, they are common. So rho L upon A is common. It's 1 upon 4 plus 8. Now help me to solve this. Now you have to cancel it. I was thinking I can also cancel rho L upon A. I can cancel 1 rho, 1 L, and 1 of the A. So I made a good cancellation here. What I'm left with? Can you help me? 1 upon 4 plus 8.
$8.25.
No, keep it in fraction.
33 divided by 4.
Sorry,
33 divided by 4.
33 upon 4. Good. Then at last one answer. Now we can, I want to find rho. So I have to make rho the subject. This 4 and this 2, they will become 8. So it will be 8 upon 33 rho L upon 8. Look like a maths paper now. Make rho the subject. Unfortunately, a letter is giving us a problem. Because we are getting 8 upon 33. And here it is no 8 upon 33. So it means after a long effort, we have gone somewhere wrong. We can find it in this way, and this is R is equal to rho L upon 12A. So rho is equal to 12AR upon L. So that is the right part of it. It's a big effort, and then it went wrong. A car has sensors for detecting the light intensity and temperature of its environment. The sensors make use of a LDR and a thermistor. The car moves from a warm and dark environment into a cold and bright environment. Now, how LDR responds? Resistance of LDR increases in darkness and decreases in brightness. If it is a regular thermistor normally what does that as temperature increases, as temperature increases, its resistance decreases. And here LDR brightness increases, resistance decreases. So then this question should be a straightforward question, 33. Now suggest the answer. It's moving from into a cold, temperature decreases, and a bright environment. So when it enters a bright environment, what will happen? In a bright environment, resistance of LDR decreases. So either it is C or D, but it is cold, so temperature decreases. Resistance will increase. A student assembles the circuit shown. Which row describes the state of the two lamps? Diodes are connected in forward and backward, and this is forward and reverse bias. And when you switch on the circuit, state of the two lamps, and this is positive, this is negative. Current goes this way, current is trying to enter from here, trying to enter from there, here, and here. Now I mark them 1, 2, and 3. 1 is forward bias, it will be conducting. 2 will be forward bias, it is also conducting. And 3 will be reverse bias. Reverse bias means not conducting. Reverse bias means not conducting. Which row describes the state of the two lamps? So lamp 1 will get the current. Lamp 2 will get some current from 2, but it won't get the current from 3.
But both will still get current, so it will be D, they're both on.
Because the option is not dimmer or brighter, but both will be on. It is getting current. It will get the current from here. From the diode number 3, it will get negligible current. Kirchhoff's first law is a consequence of the conservation of which quantity? It's a memory. Kirchhoff's first law is a conservation of
Charge.
Conservation of charge. Yes, good then. Conservation of charge. Now look at this question. It looks like a Kirchhoff question. What is the potential difference across one of the resistors? All are R. 3 identical cells have electromotive force E and negligible internal resistance. The cells are connected to 3 identical resistors, each of resistance R, What is the PD across one of the resistors? So this is plus, this is minus, this is plus, this is minus. Now, what is the PD across one of the resistors? This is a tricky question because it's a loop. It's Kirchhoff's second law. When batteries are connected in opposite polarities, their EMFs are added or subtracted. When cells are connected in opposite polarities,
They're added.
they are added, and like polarities, they are subtracted. So two cells are connected in opposite polarity. One cell is connected in like polarity. So we can work out for any resistor he wants for across one of the resistor. Internal resistance R is negligible. All the three resistors are in series. Acha, if I mark it, let me mark there because that will be easier for me. If I say this is 1, this is 2, and this is 3. Do you think 1 and 2 are cancelling each other or 1 or 2 are in the line?
1 and 2 won't cancel each other.
And 2 and 3 are cancelling each other.
Yeah.
So 2 and 3 cancel each other. Only one source is active, E. Acha, the three resistors are in series. So if just imagine the two are cancelled, so I have three resistors with one source active E. So it means how much each resistor will get. Now, this is the next question. You have to try this question. I'm just coming. try this question and then we discuss it shortly. Question number 37. Give the feedback. What answer is coming for 37? The light dependent resistor is then covered. Covered means block the light. It will be darkness and LDR resistance will increase. Ammeter gives a non-zero reading. Non-zero means resistance will increase and it's a slider. Some voltage will be dissipated across LDR. Presently it's zero. Zero means that the two voltages are equal. The voltage coming from the uniform metal wire and voltage at the point where ammeter is connected, the two voltages are same. So this is the position. Voltage this one and voltage this one. So when the ammeter is showing zero, it means V1 is equal to V2. We have covered it. Covered means that it's darkness. So LDR resistance will increase. This resistance will later increase. The resistance will increase. So voltage will be transferred to the, more voltage will come across. More voltage will come across the across the LDR. So 37, I have explained it again. So please give me the answer.
It would be C, moving the sliding contact to the left.
If you move the sliding contact to the left, actually, when you switch on, the what happens that the voltage across LDR V here will increase and V here will decrease. So we need to balance it. So when we need to balance it, we move the slider, so it will decrease. So we have to move the sliding contact to the left. When we move it left, V1 will decrease and it will come again to it will come again equal to the V2. But that was in paper. I think it would be a difficult question. What are isotopes? Looks to be simple. I think so. Isotopes are those which have the same number of protons but different number of neutrons. The nucleons vary.
So it will be C.
Neutron N10 is fired at this. The neutron is absorbed by the nucleus, which then splits to form nucleus of this and this. What is the number of free neutrons emitted when U-235-92 nucleus splits? So we can count the, we can just imagine the equation, and it's a game of balancing. So if I write the equation, this is the case. And here I have a dotted line. So now you can add up now 231 plus 1, 235 plus 1 is equal to 236. Here it is 141 plus 92. How much is 141 plus 92?
233.
233 and 236.
So you'll get
236 minus 233, it's 3. And one neutron is costing 1. So it will be 3N10. So now select the answer D, C, what? A pi plus meson has a charge of plus E, where E is the elementary charge. It consists of an up quark and a down quark. What could be the other quark in the meson? Up quark and one other quark. We need to get an answer plus E. It means I need to get plus 1E. What is the charge value of an up quark? Is it 2 upon 3E or 1 upon 3?
2 upon 3e.
It is 2 upon 3E plus
X will be 1 by 3.
so 1 upon 3E.
So it will be anti-down.
Anti down, but anti would be minus.
No, anti-down. So it would be plus 1 by 3.
Hmm. Okay, so that is all for this paper, and we are done with it, and we will inshallah put a class before that also now, because tomorrow is Sunday and the paper is on